In this video, we'll be talking about the limit comparison test and applying it to a specific example. So in this particular example, we're given this series such that we're trying to determine if this series is going to be convergent or divergent. Now we can attempt to use the limit or the divergence test, we can attempt to use the integral test, but some of these tests just seems like they're going to be more and more complicated. It's also important to note that the comparison test in this particular case would be drastically difficult to conclude anything about, because adding 5 and adding 3 to the denominator and the numerator, we don't know how that's going to overall affect the problem, as does subtracting k, a changeable value, as well as subtracting 2k squared from the top. We don't know how these things are actually going to compare universally by removing those terms. So what we're going to do instead is we're just going to go ahead and bring a series to the table that we can absolutely determine convergency or divergency. And then we're going to go ahead and just take the limit of this stuff. So it actually works quite well and simple with this. My L value is going to be equal to the limit as k goes to infinity of this stuff on top. Again, that's the series we were given. That's what we're going to always have on top. So k to the 4th minus 2k squared plus 3 divided by 2k to the 6th minus k plus 5. And we're going to divide this by another series that will allow us to actually determine and conclude convergency. Now, the way that we're actually going to do this, it's kind of slick. The series we're going to bring to the table is actually going to be us taking this and legitimately removing all those other terms. So we're going to go ahead and use a limit comparison test with this series, which is really 1 over 2k squared. And the reason why we're going to do it this way is specifically look at the setup that we were given here. You'll notice that this is definitely a p series. And with p being 2, we know that it's going to be a convergent p series. So that just means that this thing either has to be equal to 0 or has to be equal to any number other than infinity. So if I play with this series right here, I'm going to go ahead and divide it by 1 over 2k squared. But if I'm taking the limit of this concept, I can go ahead and change this fraction up to the top. It means that 2k squared is simply going to be multiplied on the top up here, and all these bottom terms are going to be multiplied by 1. So it's going to leave me with 2k to the 6th minus 4k to the 4th plus 6k squared. This is all divided by 2k to the 6th minus k plus 5. And if you recall your limit rules and how to evaluate these things, we can multiply top and bottom by 1 over k to the 6th. But what we'll end up with is most of the time with these limit comparison tests, it's real smooth that this term's going to go to 0, this term's going to go to 0, this term's going to go to 0, this term's going to 0, this one's going to be just 2, and this one's going to be just 2. So I'm left with 2 over 2, which is really just 1. And I've picked this specific series oh so smoothly so that this end result gives me almost back 1 every single time. It's the conveniency of the limit comparison test. So with this problem, very smoothly, very carefully, I've got L equals 1. So with L equals 1, by the comparison test, with the series 1 over 2k squared p series convergent p greater than 1, comma, the series k equals 1 to infinity of k to the 4th minus 2k squared plus 3 divided by 2k to the 6th minus k plus 5 is also convergent. And again, the reason why that is because of the way that we've got this rule set up. If L is something between 0 and infinity, whatever the series I brought to the table does, my series that I was asked to deal with also does the exact same thing. So that's how we can say, hey, this limit L equals to 1, so given that this is a p series with convergency, this then is also a series that then converges. I can't guarantee it's a p series, but I know it's a series that also converges.